we are going to review how to graph an exponential function. And then on the back, we are going to do one where we graph the inverse of the exponential function, which is a logarithmic function. I do have a graphing calculator, but my graphing calculator is going to be a little different from yours. And so when I type things into it, I will explain the difference on what I see on my screen of my calculator versus what you will see. So I'm going to go through one on the front, and we have f of x equals 1/3 to the power of x minus 7. So when it's asking for growth or decay, we are looking at the base that has the exponent on it. So our variable is this exponent, and it is connected to this 1/3. That will tell us if we are growing or decaying. If the number is in between 0 and 1, I'm going to write it like this, it would be decay. And if that number is greater than 1, then it would be growing. Growing is when it increases really drastically, and then decay will be when it kind of comes down and levels off. So because 1/3 is in between 0 and 1, this graph will demonstrate exponential decay. So overall, our graph will be decreasing. Our horizontal asymptote is going to be at -7. So the number on the outside of everything, either being added or subtracted on, is our horizontal asymptote. Since it is horizontal, horizontal goes left and right. It'll cross the y-axis at -7. So we are going to write it as an equation, y equals -7. So to start graphing it, I always want to start with my asymptote, and I'm going to do it in orange, and I'll do the rest in my pink pen. So at -7 on my y-axis, we are right there, and I want to do a dotted line for asymptotes because it's not part of the line of the graph, but my graph will get really, really close to that asymptote and it will not cross it. So I want to make sure that my graph is accurate and doesn't go on the other side of that line. So looking at our table, we actually already have 5 values picked out for us. If we didn't, I like to start somewhere around 0 and then adjust. So when I say adjust, I mean like if I get an output that's way too big that it won't fit on my graph, I might change my inputs to be a little bit smaller to hopefully get a different output that I can graph, and vice versa. So we're going to start with -2. We take our x value and we're going to plug it in where our variable is. So I'm going to type into my calculator that 1/3 to the power of -2 and then -7. So on my calculator, when I do a fraction, I want to put it inside parentheses. 1/3 is a repeated decimal, so I don't want to use the decimal version. So I'm going to do 1 divided by 3. To get an exponent, I'm going to hit this button right here. So it's called a caret. Mine is going to look different on my screen. So on yours, your cursor will get to be a little bit smaller in the top. Mine doesn't do that on this one. I just have a different calculator. But my exponent will be -2. So I'm first going to hit enter, and then I'm going to subtract 7 and do it in 2 steps. So I get this, but I don't want to forget that I'm subtracting 7 from it. And so in my table, my output, when I plug in -2, gives me 2. And I'm going to do that for the rest of the table. So I have my 1/3 inside parentheses to the power of -1 is our next input. And then I subtract 7 because that is part of my equation, and I get -4. And I'm going to do the rest of this to fill up my table. I'm going to round that to -6.7. And -6.9. So now that I have 5 points, 5 points is probably the minimum that you want. I'm going to go ahead and graph them. So my x value is -2. So I'm going to go over to -2. And my y value, or my output, is +2. So I'm going to go up to +2 here. I got that one graphed. So the -1, -4. My x value is -1. My y value is -4. That's my second point. 0, -6, 0, and I'm going to go down -6. Then I have 1, -6.7 is hard to do. It's going to be somewhere in there between -6 and -7. And then -2, comma, -6.9 is going to be so close to -7, but that asymptote is there, so I don't want to touch it or cross that line. So now I'm going to connect my dots. And I want to put arrows on both ends, and so my graph looks like this. This does demonstrate the decay that we thought, because as we go from left to right, our graph is decreasing. It is going down, and it is getting really close to that asymptote. I don't want to cross it. So this was an exponential graph. I'm going to do one on the back as well. So I'm going to flip this over. I want to do actually number 6 because we already did one with the fraction. So I'm going to do number 6, a little different. We have a whole number raised to an exponent. So now we need to do our original, use that information to get our inverse, and then graph our inverse. This notation right here is the notation for the inverse of f of x. So we have to find f of x first. So we have f of x equals 3 to the power of x minus 1. Right now, I kind of want to think about if it's growing or decaying. So if I did graph the exponential, it would be demonstrating exponential growth because I have 3 to the power of x and 3 is bigger than 1. My horizontal asymptote is at y equals -1 because horizontal will cross the y-axis since it goes left to right, and it's at -1 because that's the number on the end. So now I want to fill in my table. I'm going to fill it in the same way that we did on the front side. So I'm going to plug in -2 in for x and then fill out my entire table. So 3 to the power of -2, and then I'm going to subtract 1 from it. You could probably do it all at once. Just make sure that your cursor comes back down as normal for the -1, that you're not putting it in the exponent with that -2. So I get about -0.9. I'm going to round it. Then I have 3 to the power of -1. I still have to subtract 1 from it, and so I get -0.7. I get 0. Anything to the power of 0 is 1, and so 1 minus 1 gives me 0. Here I get 2. And then the last box, I get an output of 8. So I have to get my table for my original because I need those same values for my inverse. To get the table for my inverse, all I'm going to do is I'm going to switch the rows. My x value, so the top row, will now become my outputs, so the bottom row, and my outputs in my original become my inputs, or my x values of the inverse. So I would have -0.9 as the x value, the output is -2. So I'm just taking these two values and flip-flopping them, and I'm going to do it for every single point in my new table. If it's easier to do one row at a time, I have seen that causes less mistakes. So to do all of the x values from the bottom row and then all of the outputs from the top row. So now I want to graph my inverse. To help me graph, I want to identify my vertical asymptote. So it is a vertical asymptote because now it's going to be x equals -1. It's that same value from our original, but all of our y values turned to x values. That's why we flip-flopped these. So it's x equals -1. So for my vertical asymptote, an x value of -1 is right here. So I'm going to do a dotted line. And then I'm going to graph my points, and I'm only graphing my inverse. It doesn't say to graph my original. I just needed the table to get the table for the inverse. So an x value of -0.9 is really close to -1, but not quite there. And then an output of -2, so maybe somewhere there. -0.7, -1, I'm going to put that pretty close to -0.5 just because the space is small. 0, 0. An x value of 2 and a y value of 1. And then an x value of 8 and a y value of 2. So my inverse of the exponential, or this logarithmic graph, will look like this, and this side will get really close to that vertical asymptote, but it's not going to touch it or cross it. So hopefully that helps. You got one of each, so you can practice the 2.0 and the 3.0.